crew. Welcome to Pre-Calculus and your first notes video. In Pre-Cal, we build on what you've learned previously about functions, and we expand that knowledge, especially when it comes to using mathematical models to solving problems that reflect real-world situations. In these notes, we're going to review some foundational vocabulary, and we're going to define the 4 basic ways we'll be representing functions throughout the year. Let's start with the definition of a function. If y is a function of x, then for every x, there is one and only one y. A function is a special type of relation. A relation is any pairing of 2 variables. In the past, you've generally used x and y as 2 variables, and you've defined a variable as a characteristic that's described with a number that can change. For the purpose of having an example, we're going to use the characteristic of age and height. Age is our x variable, height is our y variable. So if we take this definition of a function and we replace the generic variables x and y with what they're standing for, then we could say this: if height is a function of age, then for every age there is one and only one height. So the question is that relationship true? Well, let's think about it. If we measure age in years, then on your 12th birthday, you were 12.0 years old. 6 months later, you were 12.5 years old. If on your 12th birthday we measured your height, maybe you were 5 feet 2 inches tall. In inches, that would be 5 feet times 12 inches per foot, that's 60 inches, plus the 2, so 62 inches tall. Were you that one and only one height on that particular day? Yes, you wouldn't have measured 2 different heights on that one day, so yes, height is a function of age. Tomorrow, you're going to have your first quiz. That quiz is going to have one question. It's going to be, what is the definition of a function? And if you quote this statement, you're going to have 100 on your first quiz. Now, if you give me something that is not word for word that, but has exactly the same meaning, I'll give you full credit for that as well. Let's look at a couple more terms, a few more terms that you need to know as we continue to talk about functions this year. In a function, our variables play specific rules. The dependent variable, y, changes in response to a change in the independent variable, x. In our example, our dependent variable is height. And again, we're measuring that in inches, right? And our independent variable is age, and we're measuring that in years. Again, our dependent variable is our y, and our independent variable is our x. The domain is the span of acceptable values or reasonable values for the independent variable for our x. So in our example, our domain, excuse the misspelling there, our domain for age would be the lowest age as we look at change in height, so reasonable that would be 0. At 0, the day you're born, you had height or length, up to maybe 20 years old. In interval notation, we would say that the domain is 0 to 20. I ended at 20 because for most people, they reach full height at 20 years. right? Generally for males, for females earlier than that. The range is your span of acceptable values for your dependent variable, for your y. So again, in our example, right, our range would be our reasonable values for height. So if we think about the typical person, right, the shortest they are might be, 18 inches. Most babies are between 18 and 22 inches at birth, up to, I'm going to use 84 inches. 7 feet would be a very tall person, very tall male, and 7 times 12 is 84. So typical range for the relationship between age and height might be 18 to 84. The last term I want to review is the term of an asymptote. Right? An asymptote is a line, right? And it is a line that a graph gets arbitrarily close to. Arbitrary means as close as we want it to. The idea of that is this. If we were to consider the graph of height, right, that graph, right, starts at some height and increases, and then eventually a person reaches full height. So what we see in this is that there is a line that our graph is approaching, and this line is not part of the graph, but it does relate to the graph. This is not strictly the definition of an asymptote, but it gives us that idea. We'll expand more on that later. So, in review, right, these are the things that you should know. You should know the definition of a function. You should know and be able to use, right, be comfortable hearing and using the terms dependent and independent variable, domain, range, and you should have a basic understanding of what an asymptote is. Let's move on and define the 4 basic ways that we will represent a function this year. A function can be represented, first of all, numerically. We do that when we use a set of points. So if I give you the point 0, 20, I'm telling you that at 0 years of age, an individual is 20 inches long. Or it can be with a table of values. So if I give you something like this, giving you a table, one column is for age, another column is for height. If I give you 0, 20, I'm pairing those two numbers. If I give you 12, 62, I'm telling you that at 12 years old, this individual is 62 inches. If I give you 20, 67, I'm telling you that at 20 years old, an individual is 67 or 5'7". Okay. Another way that we can represent functions is graphically. We do that with a 2-dimensional graph. So if we were to graph this situation, we would have 2 axes, a horizontal and a vertical. The horizontal is for our independent variable age. The vertical is for our dependent variable height. It's very important that we label our axes. We should also scale our axes. So I'm taking this from 0 up to 20. So halfway would be 10. This would be 5. This would be 15. And I'm looking at heights somewhere. I'm not going to have a height of 0, but from 0 up to, say, 90, where this would be 30 and this would be 60. So I have a graph, I have axes labeled, and I have scales indicated. The third way we can represent a function is algebraically with an equation. So for example, I might say y equals 20 plus 2.5 x, where x is a place I can insert an age, and the equation would give me a prediction for a person's height. Finally, we can represent a function verbally with a description. So I might say something like, a child is born at 20 inches in length and grows an average 2.5 inches per year until they are 20 years old. And that would give you a verbal description of a relationship between age and height. Okay, finally, we have the definition of a mathematical model, which is a function, and that function might be a graph, it might be an equation, it might be, right, a set of points, and that can be used to make predictions and interpretations about something in the real world. And that really is the focus of what we do in math. We use what we know about math to build a mathematical model to help us learn about the world that God has placed us in. Okay, so this is the basic information you need to know to begin our studies in pre-calc. Your next video will give you 2 examples of how we will use these concepts.